Hello aviators, Sky here, and in addition to the video on why are we flying so slow, I came up with a continuation. A sequel answering the question, will we ever fly faster? No, the end. Slow flights and boring landings to you. Well, okay, not everything is so radical. A small trip can be arranged after all. Moreover, in this case, I have a chance to argue with myself. So, let's go back to the era of the glorious Concorde and Tu-144. The supersonic airliners of the first generation were quite naturally a revolution. They were works of art, flying monuments of engineering achievement, a triumph equaled only by its monumental failure. These planes were very demanding to airfields and difficult to operate. Not every airport could work with them. Their huge engines with afterburners had insane appetites. In addition, supersonic aircraft are loud. Very loud. Upon takeoff, the planes were using afterburners, which turned the areas around the airports into acoustic hell. And breaking the sound barrier was giving the whole environment a full scale of emotions from sonic booms. This caused an even greater restriction in operations. The aircraft were simply forbidden to fly to many cities, and the supersonic speed was only allowed mostly over the seas. What do we have in the end? Terribly expensive and demanding in operations airliners, with the fuel consumption of wide-body flagships, the range of conventional single aisles, and finally, the capacity of regional planes. At the same time, these planes could only fly with a huge amount of restrictions. Check and mate. Apparently. Now let's return to our glorious 21st century. The world is ruled by economically optimal airliners with economically optimal performance. A cheaper ticket is more important for a passenger, and cheaper operation is more important for airlines. Modern airplanes pursue precisely this goal, and are quite good at it. In terms of mass air travel, considering the problems described above, the only trip a supersonic airliner can make faster is a trip to bankruptcy. And now a small remark. In terms of mass air travel, clearly no tourist will pay a few $1,000s for a ticket to a medium-class resort. But there are people willing to pay more for better conditions. What can airlines offer such people? A quick passage of procedures at the airport, elegant accommodations in cabins, or even business-class airplanes. When describing the services of the highest class of airlines in Asia or the Middle East, it is widely believed that it all comes from having too much money, that Arab sheikhs love their palaces, so they turn the planes into palaces. The fact is that in the pursuit of wealthy passengers, the airlines cannot offer anything but comfort, and all this costs insane amounts of money that the VIP passengers are still going to pay, because there's nothing better anyway. Even the most luxurious Boeing 777 still remains a Boeing 777. This raises an obvious question. Will these people be willing to pay for speed? And here, everything turns upside down. Let's go over the main problems with this assumption in mind. First, demanding airfields and difficulty in operation. This is a serious problem that is extremely significant when it comes to a 180-ton airliner. A business jet that has much smaller mass and size will be far less picky. Second, the voracious engines. And this problem remains, but again, we are talking about a business jet. Concorde and Tu-144 competed with other mass passenger airliners and lost to them. In this case, however, the market will be different. No one will be seriously comparing the cost per seat between the 20-seat Gulfstream and the 200-seat Boeing. Fuel consumption will remain pretty big, but it is not so critical anymore. Third, the noise. No one has invented the magic pill. The takeoff will still be noisy, and the sonic boom did not go anywhere. But firstly, significantly smaller dimensions will once again play their part. And secondly, there may not be a magic pill, but some vitamins have been developed nonetheless. So it turns out that, in principle, a small supersonic aircraft is a very real game. Theoretically, at least. Let's look at this idea in our time. The failure of the first generation of supersonic airliners ruined all desire to deal with this concept for a long time. All the talks about new projects often came down to a philosophy of a bright but distant future. The industry has changed too. The biggest players in the field are not particularly interested in any technological revolutions. Moreover, revolutions carry such huge risks that they are simply afraid. The prospects are not obvious, and failure promises a disaster. The logic is simple. You do not need to turn the industry on its head. You just need to create a plane that is slightly better than that of the competitors. And that is all everyone's doing. An example of such a policy was the Boeing Sonic Cruiser, when in many ways a breakthrough project was considered too risky and gave way to an excellent but much more conservative Project 787. And so, in this world of regulations, security and rationality, it takes an adventurer to make a supersonic business jet. And where can we find adventurers these days? That's right, in startups. The first thought is skepticism. A bunch of nerds will take up the case and, charged with venture investments and non-alcoholic energy drinks, will build a plane? Well, firstly, investors are able to provide very decent financing. And secondly, do not underestimate nerds, especially if they have industrial giants backing them up. SpaceX is a good example. You can hate on them all you want, but the rockets are flying. And along with NASA, they are working out technologies that would otherwise be collecting dust. A supersonic aircraft is, first of all, a risk of failure that scares the leaders so much, but can be taken by the beginners. And this is not because they are such incredibly brave innovators, but because they simply have no choice. Other markets are occupied, and frontal competition with the giants is clearly a dead end. Now, we can finally talk about a couple of examples of who and how is trying to break through the sound barrier now. Let's start with the first. This man's name is Blake Shull. He is co-founder of Boom Technology. His company was founded in Denver quite recently, in 2014, and started promoting its project of a small supersonic airliner. Their idea is rather conservative and in some ways repeats the concept of Concorde, adjusted for smaller dimensions and modern technologies. This airliner, with a capacity of up to 55 passengers in one business class and 10 in a VIP cabin, will fly at a distance of 8,300 kilometers, or 4,500 miles. Due to the speed of Mach 2.2, the plane will be able to fly from London to New York in 3 hours, and long-haul flights from Los Angeles to Sydney will take 6.5 hours, twice as fast as they do now. At the same time, the cost of a ticket from New York to London and back should be about $5,000. Quite expensive, but much cheaper than Concorde tickets. It should also be mentioned that the Boom project is not positioned as a super expensive business jet for billionaires, but an airliner for wealthy people who take the expensive first-class seats in ordinary planes. Several venture funds have already invested in the project, and Japan Airlines and Virgin Atlantic expressed interest in the future aircraft. Actually, the Virgin Group also made an investment, and the guys from Scaled Composites, the parents of the Spaceship series planes, and the giant Strutolaunch are helping with the development. So in general, it is a big avant-gardist gang. So, what is this Boom plane, recently called Overture? It is a tailless aircraft with a narrow elongated fuselage and ogival wing, already a familiar design. The aircraft is often called the Concorde 2.0. At the same time, it is much smaller and more than 2 times lighter. Its fuselage is initially being designed to accommodate only 2 business class seats in a row. Composite materials will be used as much as possible, which will improve aerodynamic quality and reduce weight. Also, there will be no droop nose. This mechanism is very complex and heavy, and with the modern technologies it is no longer necessary. As a power plant, it is supposed to use 3 low-bypass turbofan engines without afterburners. Rejecting the afterburners is logical. This mode of course adds some beauty, but it is an antonym of the term fuel efficiency. The idea to use 3 engines is a compromise. Naturally, less motors lower the cost of fuel and maintenance. But the installation of a Trinity allows to get rid of ETOPS restrictions and partially solves the problem of noise on takeoff. The takeoff thrust of each engine will be lower. Now they need to decide which engines will be installed on the aircraft. In order to reduce project's risks and costs, it will probably be modifications of existing engines. Another conservative solution. The design of the aircraft is quite classic, and it does not solve the sound boom problem. The good old roar will be weaker, but will remain. This is probably the reason why the main routes of the company remain over the oceans. At the moment, Boom Tech is creating a prototype demonstrator for testing of all solutions. The airplane, called the XB-1 Baby Boom, is about 3 times smaller than the commercial model. It has already been assembled and will make the first flight in 2019, starting a series of trials to test out the systems of the future airliner. so the current descriptions and appearance of the boom plane may be corrected due to the results of the baby's work. It is assumed that if everything goes according to plan, a full-fledged airliner will appear somewhere around 2023. Sounds good, but the boom airliner seems conservative and maybe even boring. We are talking about business jets. Isn't there anything more interesting? Well, let's look at the second example. The Aerion Supersonic Corporation appeared earlier. Its predecessor, the Asset Group, was carrying out research in the field of supersonic transport back in the 90s, under the leadership of Richard Tracy. I mention this person for a reason. Dr. Richard Tracy was working with NASA and DARPA for a long time. He was a member of a Global Hawk and X-30 projects, as well as one of the fathers of the Lear Star 600, the current Bombardier Challenger. A man who knows what he's doing. So, at one time, he was conducting research studies of an airframe with a laminar wing. Finally, seeing the potential for real use, Tracy found investors. Then, in 2003, Aerion Supersonic was formed. Technologies continued to be developed, and the concept of laminar surfaces was being tested in wind tunnels and at the NASA F-15 flying lab. In the middle of 2010s, this work crystallized into the Aerion SBJ project, which a little later was modified and renamed into AS2. And then it became even more interesting. Aerion announced that they will invest billions of dollars of their own money into the project, and with participation of many partners, including large airspace corporations, the risk became acceptable. In 2014, Airbus started to show interest in Aerion, and in 2017, Lockheed Martin joined the venture, with all of its vast experience and technology in aircraft design. After some time, General Electric joined the project and decided to develop engines. Of course, Boeing got its part as well, joining the party quite recently. A very serious team. Now let's get to the description of what they want to create. Aerion AS2 is a combination of several large streams of aviation thought. The first of them appeared in the 1950s, at the dawn of the race of supersonic fighters. At that time, Lockheed investigated the use of wings with different designs, and came to a conclusion that the thin trapezoid wing is the best at high speeds. The result of this research was the F-104 Starfighter, the legendary aircraft which turned out to be quite difficult in piloting, but was demonstrating an amazing speed performance. The design was very successful for supersonic flight, and the guys from Aerion were clearly inspired by it. The second stream of aviation thought is the NASA Quiet Supersonic Transport, or QSST, a project that is important not only for Aerion, but for all supersonic transportation. It was initiated in 2016 and included computer modeling of supersonic processes, blowing in wind tunnels, as well as the creation of the X-59 flying lab in the early 2020s. It is supposed to work out the possibility of reducing noise pollution due to the use of a number of special design solutions of the airframe, which in theory should reduce the effects of the sonic boom. These solutions are rather unusual, which is why the concepts of many supersonic airplanes look so bizarre. But their use promises to make supersonic airplanes much better, and that is what Aerion strives for. Besides, the QSST project is being developed by Lockheed Martin, the Aerion's partners, which can be very useful. And finally, the third stream of aviation thought, and the main feature of the aircraft: supersonic natural laminar flow wing. The idea is that the most aerodynamically high-quality airframe will be configured so that it will provide laminar flow in a cruise flight. Such a design should reduce the impact drag, friction, and turbulent flows on average by 20%. This technology is considered to be very promising, but so far it is not widely distributed due to the rather high demands for the quality of aircraft construction, from the design to materials and production. So, if we put all these projects together, we will get the Starfighter's legacy, excellent for fast flights, NASA's work on trying to make a quiet supersonic plane, as well as the laminar airframe, which should further improve the first two. The main challenge of the plane and the company is an attempt to create an aircraft that will potentially be able to fly not only over the seas, but also over land, without restrictions. In fact, most of the efforts are directed at that. The power plant consists of 3 low-bypass turbofans without afterburners. The concept is the same as with the boom supersonic. noise reduction, and the ability to fly without ETOPS restrictions. However, while the first has not yet decided on the engines, Aerion has the support of GE Aviation. They announced the Affinity Engine project, which works at the supersonic speeds and is created on the basis of the mass-produced and beloved CFM56 engine. The AS2 is planned to fly at speeds of about Mach 1.5 at a distance of 4,200 miles or 7,800 kilometers. The indicators at first glance are quite modest, but there is one trump card. Due to the quality of the airframe, the sound boom will almost not be felt on the ground during the flights at speeds up to Mach 1.2. The aircraft is created for 12 passengers in the VIP layout cabin. The requirements for quality of aerodynamics strongly influence the design. The cockpit and the cabin are located in front of the fuselage that is very elongated and has a complex shape. The thin wing has its price. There is no room for fuel tanks, so they are located inside the fuselage. The use of new technologies and solutions, similar to the solutions of Boom Supersonic, will also make it possible to abandon the droop nose, reducing the mass. But the layout, close to the F-104, brought with it the problem of this fighter. The AS2 is likely to be quite difficult to control at low speeds, which with modern avionics is completely manageable. However, the landing performance will not be the best. According to approximate calculations, the AS2's braking distance after landing will be about 2.3 kilometers or 7,500 feet long, an indicator comparable to the requirements of large commercial airliners. But again, many airports can handle it, although some of the regional harbors or mountain airfields will probably be almost inaccessible for the AS2. According to the plans of Aerion and its partners, the first prototype of their aircraft should appear in 2022-2023, and apparently, after a fairly decent test and certification cycle, the AS2 should enter the market by 2026. I described a couple of projects that are the brightest at the moment, although of course they are not the only ones on the horizon. The work on supersonic transport continues in many countries. There are other companies announcing plans to create a supersonic business jet. Will they succeed? The risks are very high, and most likely the majority of new companies will fail, but some may yet succeed, although the deadlines announced publicly, mid-2020s, may be too optimistic. But this isn't new. Startups tend to overestimate themselves. In addition, we have to consider another big, but not often noticeable barrier. Everything I said earlier in this video is nothing more than a flight of thought, theory, and assumptions. Great risks are associated not only with possible technical problems, but also with unclear economic prospects. In this case, it is not the supersonic business jets that are the experimental prototypes, as much as the companies themselves. Big players still prefer to watch or participate indirectly. Of course, they also have a lot of aircraft concepts, but for now, these planes are just models, created to demonstrate the vision of the future of aviation. Representatives of the giants involved in these projects admit that they will only be realized decades into the future, a rather distant prospect. Strategically, the position of these corporations consists of several main points. Firstly, the market has to confirm that it really exists. The desires of rich people are still far from stable long-term market demand. Secondly, the appearance of a new generation of engines is necessary. There is a lot of options, but now most of them are in labs and test stations, and the current models are not enough. Thirdly, widespread introduction of supersonic transport will require a significant reorganization of the industry, from the production chains and business processes of corporations to infrastructure and regulations. It may take years or even decades to satisfy these points. That is why the big players are just watching the new players who are trying to accelerate this process. So, while the first generation of supersonic civil aircraft was more of a demonstration of potential of the countries that created them, the second generation will be an attempt to prove that the time for supersonics has come. If it is successful, we can see new aircraft manufacturers, first in a very long time, and their success may stir up the big sharks, and then, finally, we will get the future of aviation we were promised back in the 1960s. But the future is the future. We will have to wait for it. On this optimistic note, the story comes to an end. Subscribe to the channel and leave your thoughts in the comments below. Fast flights and soft landings to you.